my name is Sam, and today I'm going to talk about the interesting phenomenon known as fault-free rectangles. So say you've got some dominoes. So I have a whole bunch of dominoes here that I found in my house, and let's play with these a little bit. So here's a domino. I'm sure you're probably familiar. You've got those little dots on one side and a blank side. We're mostly going to be working with the blank side. It doesn't really matter. The numbers don't really matter. The key thing about dominoes is that they are 2 inches by 1 inch. Okay, it's 2 by 1. It's a 2 by 1 rectangle. So in this video, I'm only going to be working with 2 by 1 rectangles for a couple different reasons, but one of them being that I have dominoes, so that makes it easy. But most of the work that I've found with fault-free rectangles has been done with 2 by 1 rectangles. So it works out perfectly that I have a bunch of dominoes to work with. So let's say we're playing around with some of these rectangles and we want to just make some bigger rectangle out of smaller rectangles, the 2 by 1 rectangles. And so we can do this however we want. So let's say we do some 3 wide, and then however much we want long. And you'll find that we can make a nice little rectangle here. So here we go. This is a 3 by 6 rectangle. Now the thing about this is that you can see that there are faults, what we're going to call faults here. So along this line, and way along this line. These are called faults. So a fault is where a line goes right through without cutting through any of the rectangles. If it were a fault, such as these lines here, so going there, so there's 3 of those, if you were to draw a line going down this way, you'd have to cut through this rectangle. And same for over here. You have to cut through this rectangle and split it into 2 squares. And what some people have been interested in is seeing which rectangles that you can make out of smaller rectangles. In the case of these dominoes, and even bigger ones, they're interested in seeing which larger rectangles that you can make out of smaller ones produce fault-free rectangles, so they don't have any faults. So you wouldn't have any lines that are going straight through. So let's take a look at another example of a faulted rectangle, a rectangle made of dominoes that has a fault, and a rectangle made of dominoes that doesn't have a fault, or fault-free. So here we have a 5 by 6, so 5 by 6 rectangle made out of dominoes. And now you can see there's a clear fault going down here, sort of on the right side. There's a clear fault there. And it doesn't seem like there's any other faults in it. So there is only one fault, but it does have a fault, which means it's not perfect, according to mathematicians at least. And you'll notice with a fault rectangle, because I'm going to go into sort of a reason why it's interesting or useful even, when you push, say right here, you get all this to go with you. And so if we were to do the other side as well, try to do this carefully, if you just push, you get this whole left side to go with you. But now this isn't perfect. We want a fault-free rectangle of a 5 by 6, so let's do that. Now while I'm doing this, I do strongly encourage, if you have some dominoes, or I don't know what other pieces you'd have that are in the shape of dominoes, I recommend that you try it out yourself. Now here we are. This is a 5 by 6 rectangle, which is fault-free. Indeed it is. So you can see there are no faults. If you were to draw a line, you'd have to cut through rectangles right here, and everywhere. So this is where the fault line is, and you can clearly see where the dominoes were. So that was a faulted version. Let's look at the fault-free version, and you can see, I mean, it is a different pattern, but yes, there are no faults in this one, so maybe a little bit more clearer to see. But yeah, wherever you draw a line, there is no fault to be found. Now one of the things I'm going to do in this video is I'm going to show how to prove the rules for which rectangles that you make with dominoes are fault-free. I want to more clearly demonstrate to you the use for fault-free rectangles and why it's at least a little bit interesting. For mathematicians, it doesn't really have to have a use because there's recreational mathematicians out there that do these things just out of fun. But there is actually a use for it, and that comes in brick walls and probably like tilings of floors and stuff. So say we have a brick wall here and you have some earthquake going through. And rather than trying to imitate an earthquake, let's just look at, say if we tried to apply a force, so push, say along here. As you can tell, you can get this whole top layer off if you just apply a force here. And obviously with a brick wall, you're not going to have it just so free like this. You're going to have them sort of stuck together. So this isn't really a desirable quality in a brick wall or even floor, there is actually a more desirable pattern, which is a fault-free pattern. So here I've built a fault-free brick wall. You'll see if I push on this brick, it'll push on this brick, which will push on that brick, which will push on that brick, which will push on that brick. And if we go back, which one was that? This one? It'll push on that brick, but that one will push on that brick, and then that one, and that one. So if I were to try to push maybe these four, I would actually end up having to push this whole chunk, and it's a lot harder. So let's try to push down here. Let's see what happens. And you can see it ends up pushing most of the brick wall. So this just makes it harder to destroy the brick wall or whatever. So if in an earthquake, it makes it harder for the earthquake to actually demolish the brick wall. So in principle, it could help with brick walls or tilings of floors and things like that. So the purpose of all this is just to show you that, yeah, there is a purpose and there is a use for these fault-free rectangles. All right, so say we have some rectangle and it's going to have one side length of P and one side length of Q. These just show that P is one side length and Q is the other side length. So I'm going to show how to get the first rule, which is very simple, of how to find all the fault-free rectangles that you can find with dominoes. Now in order to get the area of this rectangle, obviously you take base times height, so that's P multiplied by Q. Now the area of a domino is 2 because it's 2 inches by 1 inch. So that means that the area of this bigger rectangle has to also be even, since 2 is even, obviously. So this means that P times Q has to be divisible by 2. Okay. Now what about P and Q? Can they be even? Can they be odd? Well, the thing is, P times Q has to be an even number in order to be divisible by 2. So this means that we need to have at least one of these to be even. So either you could have P and Q be both even, you could have P be even and Q be odd, or you could have P be odd and Q be even, because that's just how it works out. If you multiply an odd by an even number, you get an even number. So at least one of P and Q must be even in order for this rule to be satisfied. So that is our rule number 1, but it is not enough yet to describe all the fault-free rectangles that you can find using dominoes. So I'm going to look at these cases to see if there are any fault-free rectangles in there, because it turns out that there's not so many tiles or dominoes, so it's actually pretty simple to figure it out. So let's look at 1 by Q. Alright, there we go, we're already done. Now I could extend this as much as I want, but as you'll find, there are clearly faults here. There's a fault here, there's a fault here, there's a fault here. So there are no fault-free rectangles with 1 by Qs. This also means that there are no P by 1 fault-free rectangles either. So now let's look at 2 by Q. So we could start building some 2 by Qs here. Now as you can see, there's 2, and then we could go as far as we want there. Now it turns out with 2 by Qs, there's only 2 ways to start it. So you could start it like this, and so however you do it, I could do that, and there's a fault. I could do this, and there's a fault. And I could start it like this, where you have one going vertical and another, and you have a fault. And so with 2 by Qs, there are only a couple different ways that you can orient them, or to arrange the dominoes. So it turns out that just by playing around with it for a couple seconds, we see that there aren't any fault-free rectangles with 2 by Q rectangles, or with P by 2 rectangles. Okay, so that was easy. It does get a little harder, but it's not too bad. Let's go to 3 by Q. Now, there are only a couple ways, again, to deal with these, and so I can play around with these, and we see that there's clearly a fault already. So that's too bad. Let's try to do something here. You could do this, and there's already a fault, because if I put one there and here, you can see there's clearly a fault there. And I think there's only one other way. So if I try to cut this off right here so there's no fault, and see where I go, and there we go, there's another fault right there. So it actually turns out there are no fault-free rectangles with 3 by Qs either, and the same for P by 3. And now let's go another one up. Let's do 4 by Qs. And now this is a little bit more difficult just because there's a couple more cases to deal with. Okay, so we can do this, and obviously you can't do that because there's a fault already. So let's do something like, well, you can't do that because then there's still a fault. Now let's try to, I'm up here, I'm going to cut it off. Boom. So there shouldn't be any faults there. And so here we are. There's 2 faults right there, so that's not going to work. 4x4, no matter how much I go, there's still going to be those faults. I could try to cut it off here, but that just creates another fault right here, so that's not going to work. So that's not going to work either. You see, I can't cut it off there because it just leaves a square, and I can't fit a rectangle in there. That's not going to work. So I believe that's pretty much all the options we have for 4x-Qs, and no matter what we do, we're always going to end up with a fault line in there. So this turns out that there are no 4x-Q fault-free rectangles either, and so no p/4 fault-free rectangles. And we could keep on going to 5x-Q, but if you remember, I showed you a 5x6 fault-free rectangle. So remember, I showed you this one, 5x6. So there are 5x-Q rectangles, so that's great. So we've encountered another rule with our fault-free rectangles, which is P and Q both have to be greater than or equal to 5. So we tested up to 5, and we know that 5 does have fault-free rectangles, and so this is one of our rules. And so this was found very simply just by playing around with dominoes and trying the different arrangements. And it turns out there is one more rule, because there's one more weird case that we have to look at. And then it turns out that those 3 rules I make are all we need in order to find all the fault-free rectangles with dominoes. So the one weird case is with 6x6 rectangles. So here I've drawn out the fault lines, every single fault line in this case, as a dotted black line here. So to start, we place a domino. Okay, so we place it here. And this cuts this fault line, and so that's not a fault line anymore. And so if you were to try to fill this out with more dominoes, but where you just have one domino breaking this fault line, then you can put 2 right here, and 2 right here, and then you'd have to break the fault line again, you see? So say if we put it over here instead, you see that, well, you could fill these out over here without breaking the fault line, but then you'd have to break the fault line again. So what this shows us is that in order to break a fault line, you need to break it at 2 places. And remember that each domino can only break one fault line. So, this one can break that fault line, but however I place it, I can't break also this fault line or that fault line. However I do it, it always breaks one fault line. And so we have a total of 10 fault lines, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 10 fault lines, and then we have each fault line being broken by 2 dominoes, which equals an area of 4 total. 2 plus 2 is 4. And then there's 10 fault lines in total, so you do 4 times 10, and we get 40. So if we were to fill it out in that way, where each fault line gets broken by 2 dominoes, it should have an area of 40, this whole square. But the square can only have an area of 36, because 6 times 6 is 36. You're going to have more area than you actually have to use, and so that's actually impossible. This means that we cannot make a fault-free rectangle with a 6x6. It's a really weird case, and it turns out that it's the only weird case that we have to deal with. So we have discovered our third and final rule, which is that P and Q cannot be equal to 6x6. And so this tells us all the fault-free rectangles in existence using dominoes. And again, this is only for 2x1 tilings. You could do this for 3x1, 4x6, 10x11, whatever you want to do. And you could find these very same rules, but they're going to be a bit different for those different tilings. Now the thing is about these 3 rules is we haven't really spelled out why these are the only 3 rules that we need in order for these to be all the rules we need. So I'm going to take a look at that and explain why these are the only 3 rules that we need. Alright, so say we have this 5x6 fault-free rectangle that I showed you earlier, and we can actually build out of this fault-free rectangle as many other bigger fault-free rectangles that we want. So all we have to do is, for this, I'm just going to flip them so it'll actually look kind of pretty, but it's just to show that these are the outer parts that I'm adding. So what we need is this little arrangement of 3 dominoes. So I'm going to place that right here. And then I'm going to take that same arrangement and I'm going to flip it 90 degrees that way. So that's going to be that, that, and that, where it's always going to sort of overhang one square onto these. And then I'm going to flip it 90 degrees again. So I'm going to do this, and then that, and then that. And then let's flip it 90 degrees once more, so we're going directly upwards and do this. And then from here, we can just fill out these spaces here with vertical and horizontal ones. So here we have this pretty beautiful looking fault-free rectangle. So if you were to look around, you will not find any faults in this, as long as I'm correct. If not, that will be very embarrassing. So with this, we can just expand any fault-free rectangle to make another fault-free rectangle. And honestly, you don't even need to know what's inside here. You could just know that inside it's fault-free. And then if you do this pattern on the outside, it will remain fault-free. And so we could keep doing this for infinity if we want. We could add more. So if I were to take a couple more and do this, so I do that, and I have it overhang by 1 like this. You could keep doing it. You could put one there, and you could put one there, and there, and there. So if I were to put these patterns, these 3 domino patterns, just like I did here, you can see that you can just fill out this space and this space and this space and this space with vertical and horizontal, respectively, dominoes. So what this means is that we can make as many fault-free rectangles as we want that are bigger and bigger and bigger. So that is when you have a 5 by 6. Now, of course, we could make this even bigger, like a 5 by 7. So why don't I do that? Okay, so here I made a 5 by 8 and a 5 by 7. So let's fill this out. And so here you could do that. Wait, nope, it's that. Right, so you can do that. Just expand it out a little bit, and you can see that all you need to do is expand it out. And so if you were to make this longer, all you need is to move this guy over, and you just have to fill it in with more vertical dominoes. And the same goes for over here. So if you were to extend it, all you have to do is just fill it out more. And so this works for any, starting with 5 by Q fault-free rectangles, and you could just build up from there. So that's great. Now, it's not perfect just yet because we should try another case, because that will only get us where we increase our P and Q by 4. So you can see that goes by 2 and that goes by 2. So P and Q are each being increased by 4. And so that's not going to get all the possibilities. So what we can do, so let's try doing a 4 by something. And as you remember, there aren't any of those. So here I'm going to try to do a 4 by, in this case, 2, 4, 5, 6, a 4 by 6. And as you remember, there aren't any fault-free rectangles with a 4 by Q, but we can still make one out of this using this method. So we have to alter the method just a little bit. So if we want to get this to work, we need to break this one. So here we have, I started with a 4 by 6, and I altered my method a little bit just to fill it out how it would work out. It's not the same method as before, but I just changed some things around. So this is now a new fault-free rectangle made out of a 4 by 6, and now it's a 9 by 10, I believe, a 9 by 10. You just add 4 to each. And then we can keep building this out. So we could use the other method if we wanted by starting out like this, and just putting those patterns all around the corners and then filling them out. Now we can keep building out bigger and bigger fault-free rectangles from here. So you should see from here, and maybe if we tried it a couple more times, you can build out and make as many fault-free rectangles that are bigger as you want. So this makes it so that PQ is always divisible by 2, because you're just adding 4 to P and 4 to Q, and makes it so that P and Q are always greater than or equal to 5, because you could just keep building up from there more fault-free rectangles from 5 and from 6 and from 7, etc. And then we still have that one outlier case, which we've proven to have no fault-free rectangles. So these are all the rules we need, and it was found pretty simply by just using some logic and playing around with some dominoes. So of course this is only with dominoes, 2 by 1 tiles. You could also do this with, like I was saying, 3 by 2, 4 by 11, 100 by 22, tiles, whatever you want. So you can keep going to ever larger tiles and find the rules for those fault-free rectangles as well. Or if you don't want to do that, I strongly encourage that you play around with some dominoes and try to get some fault-free rectangles. So there's so much more investigation to be done. You know, using multiple size tiles, you can make fault-free rectangles with, you know, more than one size of tiles. So if you were to use a 2x1 and then a, you know, 2x2 or something, you could make fault-free rectangles with multiple. If you're interested in that, in looking at the multiple size tiles, it gets a little bit more complicated. I would recommend this book, The Mathematical Gardener. It's actually a great book that helped me make this video, and it talks about a whole bunch of different things. Geometry, two-dimensional tiling, three-dimensional tiling, and just some fun games, like fun math games and problems and stuff. So it's actually a nice book if you're interested in filling out your bookshelf with another book with some fun math stuff. I recommend it. This is actually one of your best bets if you want information on fault-free rectangles, I've found. There isn't much out there, so this is one of the best resources. Oh yeah, and of course, I can't forget, how about 3 dimensions, 4 dimensions, 5 dimensions, and so on, n dimensions? That's something that people could also investigate too. Alright, that's all I have for this video. If you liked the video, I'd appreciate it if you gave it a like. That would really help me out. And if you want to see more videos like this, I make math and physics type videos pretty regularly on this channel. So if you like that, I would encourage you just to subscribe. And I also make vlogs talking about my experiences, mostly in science, and also my upcoming grad school experiences. So if you want to see more of that as well, I encourage you just to subscribe. Alright, so that's all I have. There's going to be a video there if you want to check it out, and a subscribe button if you want to subscribe if you're interested in seeing more. And that's all I have, and thank you for watching.